Operations with complex numbers, section 5.9. So today we're really going to be talking about adding, subtracting, multiplying with regards to complex numbers. Okay, so very similar operations. The only difference is now we're dealing with the letter I. As you recall, I is defined as the number whose square is -1. So for instance, we all know I equals the square root of -1. We've talked about that before, nothing new there. Today, what I'm going to show you is I squared actually equals -1. Now, when you think about that, why does I squared equal -1? Well, if I equals the square root of -1, if I square both terms, those would cancel out, leaving me with -1. So it makes sense why I squared is -1. You will have to recognize that today later on. An imaginary number is a number of the form a plus bi, where a and b are real numbers and b does not equal 0. So we're still dealing with that form right there. And then a complex number. Complex numbers are the forms of the real and the imaginary numbers. So we're dealing a lot with complex numbers today. The next part here is the complex number plane. Okay, the complex number plane is very similar but different than the real coordinate plane. The imaginary axis is the y-axis, and the real axis is the x-axis. So imaginary axis is my y-axis, the real axis is my x-axis. And if you look closely here, you see my imaginaries all have like eyes on them. Okay, that's my imaginary axis, the real is my x. So I always go real first, then the imaginary, just like I do x and then y. I'm going to plot ordered pairs. And then there's absolute value. Now, everybody knows absolute value is always what, technically? Positive, right? Okay, but does anybody know what absolute value actually measures? It's a distance from 0. Nice job. Absolute value is nothing more than distance. So down here, the absolute value of a complex number is a squared plus b squared, the square root. What formula does that look very similar to? Pythagorean theorem. That's exactly where it comes from, actually. Because I'm finding distance of a diagonal, which would be like the legs A and B then. Okay? That's where that distance comes from. When you think about it that way, it makes a lot more sense than just a random formula. It is distance. Okay? So here's what this looks like here, this graphing of the complex numbers. We all know how to graph ordered pairs, right? So for instance, if I give you the ordered pair, let's say 2, -3. We all know to go right 2 on the x-axis, then down 3. We all agree with that, right? Today, now, they're going to give me a complex number. The complex number is 2 minus 3i. I treat it just like I would an ordered pair. That would be very similar to the ordered pair 2, -3. I go right 2, down 3. I get my coordinate 2 minus 3i. Okay, this is nothing more than the coordinate 2, -3. I treat it as my real part's my x, the imaginary part is my y value, and I can plot in the imaginary or the complex number system. So let's look and graph these. I'm going to graph and label each complex number on the complex plane. So number 1 is 1 plus I. Now really, what's the invisible coefficient in front of the I? There's an invisible 1. So that's nothing more than what ordered pair would you say? 1, 1. 1 plus I is nothing more than really the ordered pair 1, 1. Okay, so I go over 1, up 1. Boom, there's number 1 right there. Okay, that's how I would graph 1 plus I. Graph paper? No, it's okay. Number 2, it says 4i. There's just the imaginary part there. What would my real part be technically here? 0. This is nothing more than 0 plus 4i. Which, when you think about an ordered pair, that's really the ordered pair 0, 4. So it's straight right there.
How come it wouldn't be 4 plus 0? 4i plus 0?
Because your imaginary part always goes at the end. Because it always goes in the form a plus bi, where the real part comes first. Good question, though. Good question. Number 3, -2 plus 0i. What coordinate would that be very similar to, Andy? negative 2, 0, which is then this coordinate right there. That'd be negative 2 plus 0, I. Take a couple seconds, try numbers 4 and 5. Very similar. So as you look at this, 2 minus I, what really would that coordinate be, Reagan? Yep, that's like saying 2, negative 1. So we go over 2, down 1. There it is. What about the coordinate negative 1 minus 3I? What would that be similar to, Sage? Negative 1, negative 3, which is left 1, down 3. It'd be like that coordinate right there. So not too bad graphing in the complex number system. The next part is we're going to talk about the absolute value of a complex number. And again, we talk about absolute value is nothing more than we are finding distance. Okay? So really what we're finding here is we're finding the distance between, or from 0 to those coordinates. So we're finding distance from 0 to those coordinates, looking in the coordinate plane here. That's why we have to include the A and the B here. So, again, if you have something like this, you fill in zeros. If I have A and B, I fill in A and I fill in B. And I use that Pythagorean theorem to solve for my distance. So the next part here, number 6. I have the absolute value of negative 8I. Absolute value of negative 8I. Now, really, that is similar to saying 0 minus 8I. And then I square both terms, so 0 squared, negative 8 squared. 0 squared is 0. Negative 8 squared is 64. So I really get square root of 64, which the square root of 64 is nothing more than 8. Now recognize, if I do not have both terms, what do you notice about it? It's still going to be just the number. Somebody recognized that earlier. That's always going to be true. When I don't have two parts in there, it's always going to be just that number because it's a straight line distance. Okay. Number 7, I have 2 plus I, which is really just 2 plus 1I. When I plug that into then distance formula or Pythagorean theorem, either way you want to look at it, that would be similar to saying 2 squared plus 1 squared. 2 squared gets me what, Andy? 1 squared gets me what, Andy? 4 plus 1 gets me the square root of 5. Now, somebody asked a great question earlier. They go, why is it not plus or minus? Who can give me the answer to that? Why is this not plus or minus square root of 5? Why is it just square root of 5? Anybody? Because it's absolute value. And absolute value is always positive. So whenever we do it, it always will be positive. Distance is always measured in a positive direction. Yep. Number 8. Now, don't get confused on number 8. What's the absolute value of 3? It's 3. Yeah, they're going to throw some of these in there. I mean, you can think about them. Yeah, we're dealing with a complex number system, but real numbers are still true. Okay, the absolute value of 3 is still going to be 3. I could work it out with the complex number system, and that would be, 9 plus 0. Well, that's going to give me 9. The square root of 9 is still 3. It's not like anything's changed. We're just kind of adding on to what this is. Okay? Try numbers 9, 10, 11. Take a couple seconds to try these 3. So it comes from 5 squared plus negative 2 squared. Yep. Does that make sense? So that's where it gets. Good question, though. Number 10. Absolute value of 9I. What do you say, Jack? 9. That is just 9. Nice job, sir. And number 11. Absolute value of negative 4 plus 3I is going to get me what, Sean? 5. That does give me 5. Good work. Okay, and again, distance is nothing more, or absolute value is nothing more, we're finding distance. Okay, and these distances are diagonal distances to 0, basically. The next part here, we're going to talk about adding, subtracting complex numbers. Adding, subtracting complex numbers is nothing more than combining like terms, or simplifying expressions, like we had in our warm-up today. Okay, so if you look at this problem, 3 minus 2i plus 4 plus 5i. You take 3 plus 4, gets me 7. Negative 2i plus 5i, I get 3i. My answer is 7 plus 3i. Think of I as anything more like an x or a y, and you'll be just fine. The same thing with subtraction. Okay? 4 minus a negative 2, negative I minus 6i, and I combine like terms, I'm going to get 6 minus 7i. The next one's a little more complicated. This is multiplying complex numbers. For multiplying complex numbers, we have to recall I squared equals negative 1. Okay, so this is something you will have to recall. Anytime you have I squared, you can replace that with negative 1. So when I have a problem like this, anytime I see this set up, I still want to distribute. When I distribute here, I get 6i minus 3i squared. That I squared is then replaced with a negative 1, and I can simplify to get 3 plus 6i. So that's going to be the toughest part today, is recognizing that I squared can be replaced with that negative 1 and then simplified. So your answers today will always be in the form a plus bi. You always have two parts of it. You should never have 3 parts. If you have 3 parts, you probably didn't simplify correctly, or you can simplify further. The next part here, if I have 2 binomials, what process can I do to multiply those? What's the 4-letter acronym? FOIL. First, outer, inner, last. And again, recognize I can combine like terms in the middle. I can simplify I squared. And then in the end, I'm going to get 22 plus 6i. Kind of unique how that works out. So number 12 here. I have 6 plus I plus 3 minus 2i. And again, I'm adding here, so it's nothing more than combining like terms. As I look at it, I want to do 6 plus 3, which gets me 9. I plus a negative 2i, which really just gets me negative I. That simplifies to 9 minus I. And again, that's from 1i minus 2i. So 1 minus 2 is a negative 1.
Why don't you FOIL I?
Because it's adding in the middle.
Okay.
Good question. If they were combined without the addition sign in between there, then I would FOIL that. Good question. Number 13. 9 minus 3i minus 2 plus i. So again, I want to combine like terms. 9 minus 2 gets me 7. Negative 3i minus I gets me negative 4i. I'm left with 7 minus 4i. Okay. And then number 14. Now I would want to FOIL, because there's no operation between the parentheses. So now I would FOIL first, outer, inner, last. Okay. I can look to combine like terms in the middle. 6i plus 2i gets me 8i. So I have 6 plus 8i plus 2i squared. What do we know I squared is the same as? I squared is the same as negative 1. So this really becomes 6 plus 8i minus 2, because 2 times negative 1 and minus 2. Now I can simplify farther. 6 minus 2 gets me my correct answer here, which is 4 plus 8i. Okay. All right, take up a couple seconds, try these 6. Recognize some of them are adding, subtracting. One of them is distributing. A couple of them are foiling. Take a couple seconds, try these 6. All right, let's look at these here. Number 15, Phil, what'd you have?
3 minus 8i.
That is correct, sir. Nice job. Number 16. What do you have on number 16, Andy? That's all it is? Negative 2i. Nice job. Number 17. What process would you use on number 17, Bailey? You would distribute. When you distribute, you actually get 20i plus 15i squared. And then we simplify that. What do you get, Bailey? You get 20i minus 15. Now, this is correct. I will not count off if you have it that way. The best way to write that would be always write the real part first and then the imaginary part at the end. So the best part to write that problem would be negative 15 plus 20i. But that is just fine if you write that the way for now. Number 18, 6 minus 5i plus negative 5i minus 6. What do you get, John? What do you get?
Negative 30i minus 36
You're just adding. Megan? What'd you get?
Negative 10i.
That is correct. Nice job. Yeah, your 6's are going to cancel out. 6 minus 6. You're just left with negative 5i plus negative 5i. It's negative 10i. Number 19. Now you'd have to do what process, Sage? You would have to foil first, outer, inner, last. We foil there. You would have gotten, what? 6i plus 4 minus 3i squared minus 2i. And then when you simplify that, what did you get, Sage? Not quite. Andy? What do you get when you get finish that one out?
7 plus 4i.
Yeah, you get 7 plus 4i. Recognize right here, I squared is going to give me negative 1. So really this becomes positive 4 plus 3, so 6i plus 4 plus 3 minus 2i. So I just subtract my i's, then I combine my real parts. And then number 20, 2 plus 4i squared. What's that really mean, Mark? What's the squared term really mean? Like 3 squared, what does that mean?
3 times
Okay, so 2 plus 4i squared, what's that mean?
7 plus 4i plus 7. Or,
Yeah.
you just double it.
Yeah. It's 2 plus 4i times 2 plus 4i. And then what process would I use to simplify this? I would foil first, outer, inner, last. When I do that, I get 4 plus 8i plus 8i plus 16i squared, which then simplifies to, what's that simplify to? Phil, do you have it?
Negative 12 plus 16i.
Nice job, sir. That was correct. Negative 12 plus 16i is correct. Good work. And that's it today. Here's your assignment.